For thousands of years, people looked up and believed the sky never changed. The stars seemed calm, fixed, silent forever. Modern telescopes have shattered that quiet picture completely. Space, it turns out, is full of violence. Stars explode without warning. Whole galaxies collide and tear each other apart. Massive objects hide in total darkness, waiting to pull in anything that drifts too close. But among every strange and violent object researchers have ever found, one still stands apart from the rest. It sits at a distance so extreme that its light left home before most galaxies had even finished forming. It holds so much mass that scientists had to invent a brand new category just to describe it. And by almost every rule we currently understand about the universe, it shouldn't be able to exist at all. Yet there it sits, glowing steadily across more than 10 billion years of empty space. Its name is TON 618. By the end of this video, you'll understand why researchers still call it one of the strangest objects ever recorded. The story of TON 618 starts in a quiet observatory in Mexico back in 1957. The observatory sat high in the hills, far from city lights, chosen specifically because the dark skies there made faint objects easier to spot. A pair of astronomers were working on a long-term survey project there, photographing wide sections of the night sky using large glass plates coated in a light-sensitive material. This kind of work was slow and painstaking. Each plate captured a small slice of sky, and researchers had to develop it, study it under magnification, and compare it against earlier plates to spot anything unusual. Their main goal for this particular project was simple: find and catalog faint blue stars, since blue stars tend to stand out against the more common yellow and white stars scattered across our galaxy. Blue stars burn hotter than most others, and that heat gives off a distinct color that trained astronomers could pick out even on grainy old photographic plates. While scanning a patch of sky near the border of two constellations, Canes Venatici and Coma Berenices, they noticed a tiny, dim blue point of light. Nothing about it looked unusual at the time. It was faint, it was small, and it sat quietly among thousands of other points of light on that same plate. They logged it, gave it a catalogue number, entry 618, and moved on to the next region of sky. For years, that little blue dot sat quietly in the records, filed away as nothing more than an ordinary star inside our own galaxy. No one suspected it was hiding anything. The glass plates were stored in cabinets, catalogued by number, and left largely untouched. Meanwhile, astronomy itself kept moving forward. New instruments were being built, new questions were being asked, and slowly, tools were developed that could see parts of the universe that had never been visible before. The mystery of what this tiny blue dot truly was would stay buried for more than a decade, waiting for the right technology to finally catch up to it. Everything changed in the 1970s, when astronomy entered a new era. Radio telescopes started scanning the sky, picking up wavelengths of light our eyes could never see. Unlike visible light, radio waves can pass through gas and dust clouds that would normally block our view, revealing objects hidden from ordinary telescopes. When researchers pointed their instruments toward that same faint blue dot catalogued years earlier, something odd showed up. It was producing strong radio waves. That detail alone was a problem, because ordinary stars simply don't behave that way. Stars burn steadily across the visible spectrum, but they rarely produce the kind of loud radio signal researchers were now detecting from this object. Curious, astronomers turned to a more detailed method called spectroscopy. Spectroscopy works by splitting light apart into its individual wavelengths, similar to how a prism splits sunlight into a rainbow. By studying exactly which wavelengths were present and which ones were missing, researchers could figure out what an object was made of and how fast it was moving. The results were stunning. This tiny blue dot wasn't a star at all. It wasn't even inside our galaxy. Whatever it was, it lived unimaginably far away, and it had been hiding in plain sight the entire time, disguised as something small and unremarkable. That single discovery turned a quiet, forgotten catalog entry into one of the most important objects in modern astronomy. The light coming from this object showed a heavy redshift, meaning its wavelengths were stretched out, a sign that it was moving away from us at incredible speed. Redshift happens because space itself is expanding, carrying distant objects farther away from us as time passes. The more an object's light is stretched toward the red end of the spectrum, the farther away, and often the older, that object turns out to be. Using that redshift, scientists calculated its true distance. The number they landed on was almost impossible to picture, roughly 10.37 billion light-years away. For comparison, the entire universe is only about 13.8 billion years old. That means the light captured on those glass plates in 1957 had already been travelling for over 10 billion years before it ever reached Earth. It began that journey when the universe was still young, less than a quarter of its current age. Back then, the very first generations of stars were only beginning to light up the darkness, and galaxies as we know them today were still in the early stages of forming. At a distance that extreme, a single star would be completely invisible to us, no matter how large or bright it happened to be. Even an entire ordinary galaxy, filled with hundreds of billions of stars, would fade into the background noise of deep space at that range. Our best telescopes simply weren't built to catch that kind of faint, distant light without help. So the obvious question became, how could anyone see this object so clearly, from a distance that swallows entire galaxies whole? The answer to that question is where the real story of TON 618 truly begins, and it has everything to do with what kind of object it actually turned out to be. TON 618 isn't a normal galaxy, and it definitely isn't a star. It's something called a quasar. The name itself comes from an older term, quasi-stellar radio source, used back when astronomers first noticed these objects looked star-like, but clearly weren't stars. Quasars are the blazing, chaotic centers of young, active galaxies. Researchers describe them as some of the brightest, most energetic objects the universe has ever produced. At the heart of every quasar sits a massive black hole, one that is actively feeding on huge amounts of surrounding matter. Gas, dust, and even entire star systems get pulled toward it by an overwhelming gravitational force. That material doesn't fall straight in, the way a rock might drop into a well. Instead, it spirals inward slowly, forming a wide, flattened structure called an accretion disk, similar in shape to a spinning record. Inside that disk, particles crash into each other at enormous speeds, constantly colliding as they get pulled closer to the center. Friction from those collisions generates staggering heat, reaching tens of thousands of degrees, far hotter than the surface of any ordinary star. The result is a glow so intense that it radiates across the entire range of light, from radio waves to visible light, all the way up to dangerous X-rays and gamma rays. In the case of TON 618, this glowing disk is so bright that it completely drowns out the light of the entire galaxy surrounding it. We aren't seeing a galaxy at all when we look at it. We're seeing the fire burning around its hidden center, a fire so bright that everything else nearby simply disappears from view. This is also why astronomers were able to spot TON 618 across 10 billion light-years, when an ordinary galaxy at that same distance would have remained completely invisible. The quasar's glow acts almost like a beacon, cutting through the vast emptiness of space in a way normal starlight never could. To understand just how bright TON 618 really is, scientists rely on something called absolute magnitude, a scale used to measure true brightness regardless of distance. Absolute magnitude essentially answers one question: how bright would this object appear if every observer in the universe were standing at exactly the same distance from it? TON 618 measures at roughly negative 30.7 on that scale. In plain terms, this single object shines with the brightness of more than 140 trillion suns. That number is difficult to picture, so try imagining it a different way. Picture every star in a galaxy the size of our own Milky Way,
hundreds of billions of them, all switched off at once, leaving nothing but darkness. Now picture a single object taking their place and somehow outshining every one of those hundreds of billions of stars combined, many times over. That's the kind of brightness researchers are describing here.
If TON 618 could somehow be placed at the center of our own galaxy, replacing the black hole that already sits there, the effects on Earth would be immediate and severe. Its light would overwhelm our night sky completely, even from a distance of over 25,000 light-years away. It would appear brighter than dozens of full moons stacked together, turning night into a kind of endless, blinding twilight. Darkness, as we currently experience it, would simply stop existing. Radiation pouring outward from an object like this would likely strip away a planet's atmosphere in a remarkably short amount of time, leaving nothing behind to protect the surface below. Thankfully, TON 618 sits over 10 billion light-years away, far too distant to pose any actual danger to us here on Earth. But this blinding light is only the surface of the story. The true monster responsible for it is hidden deep inside, buried at the very center of all that fire, and its properties are even more extreme than the light it produces. For a long time, scientists categorized the biggest black holes using one single label: supermassive. The black hole sitting at the center of our own galaxy, known as Sagittarius A star, fits that label perfectly. It weighs in at around 4 million times the mass of our Sun, which already makes it a genuine gravitational giant compared to anything else nearby. For most of the 20th century, black holes of that size were considered close to the upper limit of what nature could produce. But next to TON 618, that number starts to look almost small. Researchers estimate that TON 618 carries a mass of roughly 66 billion suns. That makes it more than 16,000 times heavier than the black hole anchoring our own galaxy. To put that comparison another way, if Sagittarius A star were the size of a single grain of sand, TON 618 would be closer to the size of a small mountain sitting right beside it. Because of a mass this extreme, scientists had to create an entirely new classification just to describe it, a category now known as ultramassive black holes. Here's where things get genuinely strange. According to current theoretical physics, black holes are supposed to have an upper growth limit tied to how much radiation their own feeding process produces. Once a black hole reaches somewhere around 50 billion solar masses, the outward pressure of its own radiation should start pushing away nearby gas, effectively cutting off its own food supply. Scientists call this the Eddington limit, and for decades it was treated as a hard ceiling on natural black hole growth. TON 618 sits at 66 billion solar masses, comfortably past that supposed ceiling by a wide margin. By the numbers alone, it shouldn't have been able to grow this big, at least not through any process astronomers had previously mapped out in detail. And yet, here it is, sitting quietly in the data, breaking a rule that was never supposed to be broken in the first place. This single fact alone has forced researchers to rethink parts of how black hole growth actually works under extreme conditions. The sheer physical size of this object matches its staggering mass. The outer boundary of a black hole is called the event horizon, the point beyond which not even light, the fastest thing in existence, can escape its pull. For TON 618, researchers estimate that boundary stretches across roughly 400 billion kilometers. To put that into perspective, think about our own solar system. The distance from the Sun out to Pluto measures around 5.9 billion kilometers, a distance that already takes light itself several hours to cross. You could take our entire solar system, every planet, every moon, all the way out past Pluto's orbit, and drop the whole thing inside TON 618's event horizon. It would disappear completely, swallowed without a trace, with enormous room left over for dozens of other solar systems to fit alongside it in that same space. This isn't just a big black hole sitting somewhere out in the dark. It's an abyss on a scale that barely fits inside human imagination, a boundary so large it could contain thousands of solar systems the size of our own. To really grasp what an object like this means, imagine approaching it yourself, safely, inside your own thoughts. Picture a small, well-shielded spacecraft drifting slowly closer, instruments recording everything along the way. As you drew closer, the first thing you'd notice would be twisting magnetic fields, coiling tightly around the black hole's outer edges like invisible ropes of energy. Those fields fire off enormous jets of glowing plasma, blasting outward from the black hole's poles at nearly the speed of light. Researchers believe jets like these can stretch for millions of light years, reshaping entire galaxies by pushing gas away and slowing down the birth of new stars in the surrounding region. Watching one of these jets up close would feel like standing near a beam of light, powerful enough to outshine entire star systems. Moving past those jets, you'd reach the burning accretion disk itself, spinning at speeds that stretch far beyond anything found naturally on any planet. Its glow would be blinding, far brighter than anything a normal star could ever produce, lighting up your entire field of view in shades of white and blue. Beyond the disk, you'd start to notice something eerie. A faint ring of light curling directly around the black hole's edge. That's actual light being bent by gravity, trapped in a tight orbit before eventually spiraling inward and disappearing forever. Time itself would begin behaving strangely the closer you got. Gravity this intense slows the passage of time near the black hole compared to farther away, a real effect predicted by Einstein's equations. A single second for you, hovering near the edge, could stretch into years or even centuries for someone watching safely from a distance. To that distant observer, you would appear to move slower and slower, eventually seeming to freeze completely in place, caught forever at one single moment. You would become a faint, fading presence, trapped at the very edge of forever, visible but never quite gone. As you neared the final stable point, the black hole would fill your entire field of view, a perfect circle of absolute darkness ringed by fire. Even the colors around you would start to shift. Gravity this strong stretches light waves, pulling them toward the red end of the spectrum, a process scientists call gravitational redshift. Bright starlight would slowly turn deep crimson, as if the black hole were quietly draining color out of the universe around it. And once you cross that final boundary, the event horizon, there would be no turning back, no signal, no light, and no way home. Beyond it lies only collapse, a place where matter is crushed down toward a single point, and our current laws of physics simply stop making sense. Researchers are careful to point out that this journey is purely a thought experiment. No spacecraft and no living traveler could ever actually survive an approach like this. But picturing it this way helps explain just how extreme the environment around TON 618 truly is. The very existence of TON 618 raises a question that still keeps astronomers up at night. Supermassive black holes are thought to start small, either from the collapse of early massive stars or from the direct collapse of dense primordial gas clouds in the early universe. From there, they're expected to grow slowly over billions of years, pulling in gas, swallowing nearby stars, and merging with smaller black holes along the way. That slow, steady process is generally how scientists explain the black holes we see closer to home. But TON 618 sits over 10 billion light-years away. We're seeing it exactly as it looked when the universe was still incredibly young, likely only a few billion years old at most. To reach a mass of 66 billion suns in that short amount of cosmic time, it must have grown at a pace scientists still struggle to fully explain using our normal models. One possibility researchers have proposed is that it started out unusually massive from the very beginning, giving it a serious head start compared to other early black holes. Another possibility is that the early universe simply offered far more extreme feeding conditions than researchers previously believed, with denser gas clouds and more frequent collisions available to fuel rapid growth. Either way, an object like this forces scientists to reconsider how quickly galaxies and their central black holes can actually form and grow. It suggests that the rules we've built from studying nearby older black holes may not fully apply to the extreme conditions that existed billions of years ago. TON 618, in that sense, isn't just a record holder. It's a direct challenge to some of the basic assumptions astronomers have relied on for decades. As overwhelming as TON 618 seems right now, modern physics suggests that even this giant won't last forever. Trillions of years from now, long after every star in the universe has burned through its fuel, the cosmos will enter what scientists call the degenerate era. At that point, the universe will be a cold, dark place, filled only with dead stars, drifting planets, and black holes, with no new starlight left to illuminate anything. In that far future, black holes will effectively rule an empty, silent universe, the last remaining structures of any real size. But according to a process predicted by physicist Stephen Hawking, known as Hawking radiation, even black holes slowly lose mass over time. They evaporate, incredibly slowly, releasing tiny amounts of particles and energy bit by bit across unimaginable stretches of time. For an object as massive as Ton 618, that process would take an almost unthinkable stretch of time, roughly a googol of years, a 1 followed by 100 zeros. For comparison, the current age of the universe, at under 14 billion years, is such a small number next to that figure that it barely registers as a fraction. But eventually, deep in the far, far future, even this 66 billion solar mass giant would fade away completely, losing mass at a slow, steady pace until nothing remained. Its ending would come quietly, as one last faint burst of energy, disappearing into an otherwise silent and empty universe, with no witnesses left to see it happen. Until that distant ending arrives, Ton 618 continues serving a very different purpose here in the present. Objects like this act as natural time machines, carrying information about the early universe across billions of years of empty space. Because their light travels for so long, it passes through vast clouds of ancient gas scattered across intergalactic space along the way. By studying that light carefully, researchers can measure the chemistry of the early universe, identifying which elements existed and in what amounts. They can also trace how dark matter is spread out across space, using the way light bends and shifts as it passes through invisible clumps of matter. On top of that, studying quasars like Ton 618 helps scientists understand how the very first galaxies formed and evolved during the universe's earliest chapters, long before most stars we see today ever existed. In that sense, Ton 618 is both a destroyer and a guide, a violent, overwhelming object that also happens to illuminate the deepest, oldest parts of our cosmic history. Every time astronomers study its light, they're not just measuring one strange, distant object out in the dark. They're getting a small, valuable glimpse into conditions from the very beginning of everything we currently understand about the universe. Somewhere out there, across more than 10 billion years of empty space, a black hole that shouldn't exist is still quietly burning, and researchers are still trying to understand exactly how it got that way.